Good morning students, a very warm welcome to the class, and today we will start physics portion from light. Very important topic from this. Most of the questions are from this chapter in your exams. So today we will start this chapter, that is light. Okay. So first of all, very small question is that what is light? Simply we will say that light is a form of energy that enables us to see. Without light we can't see nothing. When the light rays reflected on any object, then that object reflects back that light rays, and these reflected rays when stuck on our eyes, then it forms an image, and our mind is ready to understand that what is that image, and so suddenly we will say that we will see or the objects are visible to us. So light is a form of energy which enables us to see. Okay. So now move to the next slide. What is light? Light is a form of energy that enables us to see. Okay. When light rays falls on any object, the rays reflected back on our eyes, hence it makes visible to see. Okay. So what is light? Light is a form of energy that enables us to see on any object when light rays falls on it, and these light rays reflected back or bounce back on our eyes, then we suddenly say that what is that object. So note down about the light. Okay. So some of the features about light. Light rays always moves in a straight line. Okay. Light rays is always moves in a straight line, so you have to note down this point also. Okay. And one other point is that okay, we will write here speed of light equals to 3 into 10 power 8 meter per second. Okay. So you have to note down 4 points here. First one is what is light, how it enables us to see, nature of light, and some of the characteristics. These 4 points you have to note down in your notebook. So move to the next slide. Next one is say that the nature of light. We will study about the nature of lights. So there are the three natures. First one is ray type, how the light travels as a wave pattern and as a particle form. Clear? So nature of light, most of the phenomena are different in the nature of light. When we considered about rays, the different phenomena are there. when we study about the wave nature of the light, different phenomena are there. Okay, so let us see, study one by one. So first one is ray type. First one is ray. See, when the light travels in simply this type of manner, in this manner, simply ray form, so the phenomena involved in this, you have to write that phenomenon involves, first one is reflection, second one is refraction. Clear? Reflection and refraction both are the phenomena that comes under the category of ray nature of light. Clear? Now move to the next slide. What is the wave nature? When the light travels in the wave form, when the light travels in the wave form, then this nature we have to say that it is the nature of light, and the phenomena involved in these are interference of light, second one is diffraction of light. Okay, so these are the few phenomena you have to study in your class only about reflection and refraction. These topics you have to study in a higher classes. We will just sorry we will just taking a smart note about the nature of light. And the third one is particle nature. Particle nature comes under the category of particles comes in the packets of energy called photons. When the packets of energy, when the light travels in the form of packets, and these forms of packets is called the photons, and the phenomena comes under this, that is photoelectric effect. Photoelectric effect. Clear? So you have to understand these all the topics. Now move to the next slide. We will just study about the reflection of light. So our topic start from here as a fresh. What is reflection? So when we talk about the reflection, when a light rays falls on any object and that light bounces back, this process is called reflection. So what we called, remind it, what is reflection? Reflection is a process by which the light rays falls on any object and it bounces back. This process of the light is known as reflection. So what we write here, the bouncing back of light when it incidents on any object. Clear? So this is called reflection. Suppose this is your any object and the light rays falls on it and it suddenly bounce back. This simple process is called reflection. Further we will study about the reflection, deep topic, what are the terms involved in the reflection, we will clear all the things. Okay, so just listen me carefully and note down all these topics what I am writing here. Clear? Okay, suppose we have a surface, that one is a reflected surface and that surface is a polished surface. If the surface is not polished, the reflection is not occurs properly. Okay, so we have a smooth surface or we see right here polished surface. Polished surface. Clear? Okay, this one is a polished surface. So when a when a light incident on it, when a light incident on it, this one is called incident ray. This one is called incident ray. So first term is that what is incident ray? When any object, when on any object a light ray falls on it, then that rays are called incident rays, and then these bounces back. So after incidents and while striking on this surface, the rays bounce back. So the bounce back light, back ray is called reflected ray. What we called? Reflected ray. Clear? So this one is incident ray and this one is your reflected ray. Now the third term comes. Third term is what? Third term is the perpendicular line to the point of incidence. This one is your point of incidence. So the third term is point of incident and this one is your normal. So now we will hear about 4 points: incident ray, reflected ray, normal and point of incidence. So we have to, on third, what is normal? Normal is a perpendicular or imaginary perpendicular line on the meeting point of incident ray and reflected ray, and that meeting point is called point of incident. Clear? So after this, two new terms occurs. That one is, first one is angle between incident ray and normal, and angle between reflected ray and normal. So the incident ray and between the angle between the incident ray and the normal is called angle of incidence and is denoted by I, and the angle between reflected ray and normal is angle of reflection is denoted by small r. Clear? So these are the points you have to study in the reflection of light. So take a screenshot and we have to move to the next. Clear? So now we have to discuss what are the laws of reflection. Laws of reflection, there are the two laws. First I am explain, and after that we will discuss thoroughly. So first law is that the angle of reflection is always equal to the angle of incidence, whatever be the angle of incidence, and it must be equal to the angle of reflection. And you know that the angle of incidence is always between the normal. We will not take, suppose this one is your angle of, this one is your polished surface, and this one is your incident ray, this one is your reflected ray, and this one is your normal. You will not take the angle of incidence between polished ray and incident ray. This one is the wrong way. The angle of incidence is always between the normal and the incident ray. So this one is your correct one. Most of the students in the numerical problems, most of the students do this. So we have to aware from this. The angle of incidence is between normal and incident ray, and similarly the angle of reflection is always between the angle of reflected ray and the normal. Clear? Okay. So I am telling about the laws of reflection. So first law is what? Angle of incidence is always equal to the angle of reflection. Clear? So we write here angle I is equal to angle R. What is second law? Second law is that the incident ray, the normal and the reflected ray always meet on a one point on the reflecting surface, and that point is called point of incidence. So you write here the incident ray, the reflected ray, and normal always lie on the same plane, that is point of incidence. Clear? So you have to note it down, these 2 points about the laws of reflection. Okay. So note it down. Now move to the next slide. You just prepare about the laws of reflection. Okay. Now we have to take a simple numerical. We just take a simple numerical, is that the angle between incident ray to the reflecting surface of an object V 45 degree. 45 not we will take 60 degree. Find the angle of reflection. You have to find the angle of reflection. Clear? So the question, listen the question, read the question carefully. The question is that the angle between incident ray and the reflecting surface. Suppose this one is your reflecting surface and the incident falls as this. Clear? In question, the question is given that the angle between incident ray and reflecting surface, so the given angle is this one, and I already told you that you will not take the angle between reflecting and incident. The incident angle is always between the normal and the incident ray. Clear? So if we draw a normal, that one is a perpendicular from the point of incident, and this one is your reflected ray. So this is your what? This is your I and this one is your R. Clear? So this is your I and this is your R. Angle I, angle R. And you know that when a parallel line, when a perpendicular is drawn from any point, then this angle is how much? Then this complete angle is of 90 degree. If this one is 60, then how much is 90? So you see that I plus 60 degree equals to 90, because this one is a perpendicular. So before complete this angle is of 90 degree. So here you see that 90 minus 60, so the value of I is 30 degree. So you know that what is I comes, I is a 30 degree. Similarly, if I is 30 degree, therefore R is also 30 degree. By which law? By the laws of reflection. The laws of reflection tells that the angle of incidence is always equal to the angle of reflection. So angle R is not 60 degree, and you know that in your option, one option is also 60 degree. So you will not take the option 60 degree, and the correct answer is 30 degree. So these types of numerical we will continue to the next class. Now move to the regular and diffuse reflection. What are the regular and diffuse reflection? Let us see. If any surface, that one is a plane or smooth surface. So first point is that regular reflection is always occurs on smooth surface, or we can say that the plane surface. Clear? So if any line or incident on a reflecting surface, it goes parallelly. Clear? So this type of reflection is called regular reflection. Clear? When the reflection, when the incident rays strikes on the smooth surface and it bounces back parallelly to that, from that surface, and this one is called regular reflection. Clear? So regular reflection occurs on smooth surface, on smooth surface, or you can say that the plane surface. Clear? Now we will just discuss about the diffuse reflection. So diffuse reflection, just opposite, it is on the rough surface. It occurs on the rough surface, dull surface. Clear? So the light strikes on it, it becomes to this side. When another light, it becomes this side. Okay? So that not a format pattern is followed on the rough surface. Clear? So this type of reflection is called diffuse reflection. What kind? Diffuse reflection, and it occurs on rough surface. Which surface? Rough surface. Clear? Now move to the next slide. Just a minute. Okay, what we studied here? We will study that about the regular reflection and the diffuse reflection. Clear? So now move up to the next slide. So here we will study about the images or types of images. Clear? So what is image? You simply know that after reflection the image is formed, only then we are visible to see that object. Clear? So simply we just take an example. Suppose this object is here and the light rays falls on it, and this object reflect back the light. These are the reflected rays, and these reflected rays strikes on our eyes. Clear? And the image forms on our retina, and that data or that image is read by our brain. Then only we will say that this one is a pen. Clear? Or stylus. Clear? So on our retina the image is formed is real and inverted. So the first type of image is real. Okay, so there are two types of images. First one, these are real images, and second one is virtual images. Clear? So what is an image? The when an image formed, the image is formed only by the reflecting back of the lights. Clear? So types of image, we just read that there are two types of image. First one is real and second one is virtual. So what is an real image? Real image is always forms by the actual intersection of or actual meet up of the reflected rays. So we will write here real images are formed by the actual meeting or intersection of light or reflected rays. Reflected rays. Clear? So real image is always formed by the actual meeting or intersection of the reflected rays. Clear? So, and the real image, about the real image, you have to note that it is formed on the screen, or you can say that it can be obtained. It can be obtained on the screen. You just see that the real images can be obtained on the screen. Okay, and the nature of real images, nature of image is always inverted. Clear? Whenever there is a real image, then the image nature of that image will be inverted. Clear? So why, which, let us clear this. Take a screenshot and move to the next one. Clear? It can be formed on, it can be formed by convex lens. Clear? And it can be formed by concave mirror. Clear? So the real images and image formed on our eyes, this is also a real image. So these are the some basic points about the real images, you have to note it down. Now move to the next one. What is a virtual image? Virtual image is that image which is formed by the imaginary meetup of the lines of the reflected rays. Imaginary meeting up of the reflected rays is called the virtual image. So the image, we will write here, the image is formed by the imaginary meetup of the reflected rays. Clear? So this one is called virtual image. So the image formed by plane mirror, image formed by plane mirror is called virtual. And the nature of virtual image, is always erect. Clear? Suppose this is an object, so the image of this object is also this type. Clear? So this one is the erect image. If we talk about the object, about the erect image, inverted image, this one is your inverted and this one is your erect image. Clear? So these are the images found by the virtual, and for example we will take image formed by concave lens. Clear? And the image formed by convex mirror. Clear? So these are the images found by the virtual images. Now move to the next one. Now we will have to discuss about the mirror. Mirror is that surface, or mirror is that surface which one side is a polished, and the whatever be the light strikes on it is totally bounced back, totally reflects the light. That object is called the mirror. So mirror is a kind of object which is one side as a polished surface, and whatever be the light strikes on it is totally reflects the light. This is known as the mirror. Clear? So there are two types of mirror. Types of mirror. ठीक है? First one is plane mirror, and second one is spherical mirror. Clear? We have to studies about the plane mirror. We have to discuss here about the plane mirror. See, this is a mirror, and the another surface is, I just already told you that another surface is polished. Clear? So this one is your plane mirror. Clear? This one is your plane mirror. Whatever be the light falls on it, it totally bounced back. And there is a one rule: when a light ray perpendiculars to the normal, and it simply back to same path. Clear? So this one is your plane mirror. Now we will discuss here how the image forms on a plane mirror. Let us see. Suppose this one is your plane mirror. Clear? And this one is your principal axis, and this one is your object. Clear? So if we take a line strikes on it, it suddenly, this one is your incident ray, this one is reflected ray, and you know that to make a ray diagram of any image or object formation, at least we have required number of rays we have to take 2. At least 2 number of rays we have to take for the formation of an image. So we have to take another image, another ray for this. Clear? This one is also a incident ray, and it simply back to the same angle. Now just now we have to you see that the lines, these are not meeting, and whenever the lines are not meeting, up to then the image is not formed. So we just produce these lines to the back side, so the image formed here. Clear? And I told in the previous slide that what is a virtual image. Virtual image is formed by the imaginary intersection. You see that this one is your imaginary lines, clear, imaginary intersection of the reflected rays, this one is your image. So you see that this is the virtual and erect image, virtual and erect image. So this is the image formation by a plane mirror. Let us see to the next slide. So what are the characteristics of the images formed by the plane mirror? First, a very characteristics that image is virtual and erect. Clear? Image is virtual and erect. Number 2, what is the another condition? The size of image is equal to the size of object. Okay, understood. Now the third characteristics about the plane mirror is the focal length of the plane mirror is infinite. Clear? So this is very important point regarding the characteristics of the plane mirror. Okay, so plane mirror have 3 characteristics and still there are 2. So let us move to the next slide. So number 4 characteristics, that the distance between object and mirror and the distance between image and mirror is equal. Clear? The third characteristics, that the distance between the mirror, suppose this one is your mirror and the object is kept here. So the distance between mirror and object is equal to the mirror and the image. Clear? And the fifth condition is that the image is laterally inverted. Clear? So the image is laterally inverted. What is the meaning of this statement? Suppose I standing in the front of the plane mirror. Clear? If my right in the this side, so when you see in the mirror and the image right of the image is on the left side, so right becomes left and left becomes right. Clear? So in the images of the plane mirror, right of the object is in the image of the left and right of the object is left of the object is visible in the plane mirror is that to be right. So these are the 5 characteristics. Let us see, if the object is here, suppose this one is the u distance from the mirror and this one is the v distance from the mirror. So fourth condition is that u is equal to v. If the object is here, clear, and the distance between the mirror and the object is also equal to this one. You see that size is also equal, nature is virtual and erect. Clear? So these are all the conditions you have to study. Clear? Now move to the next one, uses of plane mirror. We will also discuss about the use of plane mirror. So let us see. first we use is that in looking glass, ठीक है, we have to see our face or our body in the glass. That one is the looking glass. In looking glass, plane mirror use. Second one is periscope. Clear? Third one is kaleidoscope. In all these, the plane mirror is used. We will discuss about the periscope. You see that this device is just used by our soldiers or any spy. Suppose this kind of device is used by our soldiers. Suppose if we see visible to the sea on the height, and the enemy just shoot it out. So for this we have to use this device. So in this there is a plane mirror here and there is a plane mirror here. When the light rays suppose this one is the small hill type, and our soldier is hiding himself behind this, and he wanted to know the area. Clear? So the light rays strikes on it and just strike on it, and that is our soldier's eye. Clear? So he simply visible this area. He simply visible this area by hiding himself behind the hill, and from this place he suddenly saw the area of this side. Clear? So in these mirror is called plane mirror. So the use of plane mirror is most of them important. Okay. So I think we have to stop here for the physics class, and we just started the next lecture of this class soon. Now we have to take a look on the chemistry. Clear? So in chemistry topic we will discuss about the first chapter, chemical reactions and equations, very important chapter, and in this chapter we have to discuss here about the types of chemical reactions. Okay, we have to discuss here about the types of chemical reactions. Okay, we will discuss about the types of the chemical reactions. Let us see. The very first type of reaction is the combination reaction. So what is combination reaction? In combination reaction there are two different compounds, two different elements when combined together to form a new compound. Clear? So let us see. When any A compound is just added to the next compound and forms a new compound, that is AB. So this one is the A compound and this one is the B compound, and they suddenly mix up and forms a new compound. So this type of reaction is called the combination reaction. Clear? Let us move to the examples. First example is that CaO plus H2O. CaO plus H2O. This is what? This is quicklime, calcium oxide. Clear? And this one is your water. Simply add on and this becomes CaOH whole twice plus heat. Clear? When we mix up these together, quicklime and H2O, clear, and it forms calcium hydroxide. It forms calcium hydroxide, or the general name is called slaked lime. and by the general name it is called slacked lime. And a very important thing is that about the slacked lime, in houses it is used as white washing walls. Clear? In our houses, on our walls, clear, we will apply this solution CaOH whole twice. So on combining CaO and H2O, it suddenly forms CaOH whole twice, that is calcium hydroxide, or commonly known as slaked lime. What we called? Slaked lime. And the use of slaked lime, most of the times the examination, in your examination the question is asked which compound is used as the white washing wall. The question simply says that the CaO plus H2O, and here it says that X is the compound that forms, and you have to know about the X and what is the use of X. Now move to the next example, C6H12O6 and 6O2. This one is the example of respiration. In respiration, whatever we eat and the energy, whatever we eat, all the carbohydrate, vitamins, all separates from the food and consumed by our body, and these are suddenly changed into glucose, and these glucose when combined with oxygen, it forms carbon dioxide plus water and energy for our daily routine. So whenever we balance this one is 6CO2 and H2O. So when glucose is combined with 6O2 and it forms carbon dioxide and nitrogen and few amount of energy, and these amount of energy, how much? This is 38 ATP. Clear? 38 molecules of adenosine triphosphate just stored in our mitochondria, and whenever our body required some energy, then this energy just sent to the cells and consumed by our cells for giving us energy. Clear? So this respiration is also an example of combination reaction, and further in the combination, this is also an example of exothermic reaction. This one is also an example of exothermic reaction. So what are the exothermic reactions? Whenever in any reaction, during any reaction, the energy evolves, then this is called the exothermic reaction. Suppose when sodium is just moisturized with water or just reacted with water, and the reaction is, wow, what kind of reaction? This is exothermic. And iska just opposite, that is endothermic reaction. Endothermic reaction, what is endothermic reaction? During the reaction we have to give energy to form a reaction, to happen a reaction. This one is called the endothermic reaction. So whenever glucose is combined with oxygen, it becomes CO2 and H2O gives energy. This is also the combination reaction. Now move to the next type of reaction, that is decomposition reaction. What is a decomposition reaction? Let us see. If any AB, this one is a compound, and by any process, we can say that by giving heat or in the presence of sunlight, or we have to do the photolysis. Simply photolysis is these both are the same, or we can say the electrolysis. Okay. By any kind of process, if Fe is just broke down into two different A and B, between two, clear, A and B. So this type of reaction is called what we called decomposition reaction. So let us move to the example. When CaCO3 is broken down by giving heat, it becomes CaO and H2O. Clear? Not H2O. CaO and CO2, carbon dioxide gas releases when calcium carbonate, this one is calcium carbonate, and this is also known as limestone. This is also known as limestone. Clear? Calcium carbonate, or we can say live on heating it comes in the CO, that one is quicklime or calcium oxide. Clear? And the carbon dioxide gas releases. Clear? So this one is an example of CO2. Now similarly AgCl, when AgCl comes in the sunlight, when on AgCl sunlight forms, it is an aqueous solution. Clear? So Ag and Cl2. So Cl2, the 2Ag, then this one is clear. This one is gas and this one is solid. So whenever AgCl is comes in the sunlight or react with sunlight, then Ag forms and Cl gas is formed. Now the question is that, note it down, in most of the times in your exams it is asked that how we cannot kept the AgCl bottles, silver chloride bottles in sunlight, we have to kept in dark. So reason is that when suppose this is your bottle, okay, tight bottle, and the sunlight is just formed on, and in this is AgCl. When sunlight is strikes on this bottle, suddenly the process start. AgCl is formation, and in the tight bottle, if Cl gas is formed, ultimately chlorine gas is just spread out or blast in that bottle. So it is necessary, it is very important to keep the AgCl bottles in the dark. So this is the only reason, because if the bottle is tightly packed, so the gas wanted to spread out, therefore if the pressure becomes high, so it suddenly breaks up. So that's why we will say that AgCl bottles we have to keep in dark area. Clear? Now move to the next one, that one is displacement reaction. What are the displacement reaction? Let us see. Suppose that if there are a compound AB and another C, and suddenly B is replaced by AC, this one is, and you show that B is displaced from AB. So this type of pattern is formed by the displacement reaction. Move to the example. Suppose ZnCOSO4, so it becomes ZnSO4 plus Cu. Clear? So this is the example of displacement reaction. In reactivity series, you know that Zn is highly reactive than copper, so zinc can be replaced copper and joins with SOSO4, and Cu is replaced by zinc. So this is the example of ZnSO4. Similarly, Pb plus CuCl2 copper chloride, so it becomes PbCl2 and plus copper. In reactivity series, lead is highly reactive than copper, therefore it combines with Cl2 and forms lead chloride, and copper is displaced. So these are the examples. Now the last example, last type of reaction is that double displacement reaction. Here we in previous slide that we see that the single displacement reaction, there is a double displacement reaction. Suppose there are compound AB and different is CD, and A is connected with this and B to C. So you see that here there is a double displacement. Clear? Displacement occurs by 2 times, so the reaction is called the double displacement. So this pattern is followed by double displacement reaction. Example, Na2SO4 and BaCl2. Simply NaCl plus BaSO4. You see that this Na is connected to Cl and this SO4 is connected to SO4. So this one is your common salt or sodium chloride. Clear? And this one is your barium sulfate. clear hai? So this is an example of double displacement reaction, and the neutralization reactions are also an example of double displacement reaction. Let us see what is, first of all we have to understand what is the neutralization reaction. When an acid react to any base and it forms salt and water, this type of reaction is what we call it neutralization reaction. Suppose we take any acid, that one is HCl, and any base, suppose we will take a base NaOH. So this Cl is just connected to Na and it becomes NaCl, and this H is just connected to OH and it forms H2O. So this one is also an example of double displacement reaction. So you see that neutralization reaction. So there is a very important application of the neutralization reaction. Suppose if we have acidity, clear? So when we suffers from the acidity, it means you in your stomach the amount of acid increases. So how this can be neutralized? So doctor gives you the solution of MgOH whole twice, magnesium hydroxide, and this one is called milk of magnesia, and it suddenly neutralizes, and you feel that after taking this solution you feel relaxed. So the role of neutralization reaction is very important in daily life, clear? So acid is just added to the MgOH whole twice, that is magnesium hydroxide, and is simply known as milk of magnesia. What we call it? Milk of magnesia. In exams, the most times this question asked. Okay, so you have to note it down. So now move to the next section, that one is your biology, and in biology we have to discuss about the circulatory system. In circulatory system we have to read. So what is circulatory system? Let us discuss. The transportation of minerals, oxygen or food with the help of blood from one part to the all part of the body is considered in the circulatory system. What we understood? The transportation of food or oxygen or carbon dioxide, whether it is useful or unuseful, the transportation occurs in the circulatory system. So this one is called the circulatory system. So circulatory system, we have to discuss the organs involved in the circulatory system. If we are about the talks about the organs, the first one is blood, heart, clear, blood vessels, and the lymph, clear? So these are the organs involved in the blood. You know that the blood is a tissue called connective tissue, clear? Blood is a kind of tissue, comes under the category of connective. It is the largest connective tissue in our body. So heart, it pumps the blood with high pressure to reach up the all parts of the body, and in blood vessels you just see that you read about the arteries, veins and capillaries, clear? So what are arteries? Arteries are the thick walls, tube like structures which carries oxygenated blood from heart to the all parts of the body. And what are veins? Veins are the thick, thin tube like structures which carries deoxygenated blood from all parts of the body to the heart. And what are capillaries? Capillaries are just, suppose this one is your cell and this one is your artery, clear? So just artery is a main artery, clear? So capillary is divided to this. So by with the help of the connection between the cell and the artery to take up the minerals or give up the minerals is just happened by the capillaries, clear? Now move to the next. So in this lecture we have to study about the working of heart, how the heart works, clear? Let us see. There is a diagram you just see here, that we discussed how the heart works. Clear? So you see that these are our lungs. Clear? What are these? Are our lungs. This is a pulmonary. This is a pulmonary vein. This is a pulmonary vein. Clear? This one is artery. This one is artery, and these are the organs, different organs. Clear? And this one is vein. Clear? And this one is your pulmonary artery. Clear? And this yellow structure, you see that this one is septum. Clear? Now let us see, the naming is done. So in lungs, the blood carries oxygenated blood. So from the lungs, the oxygen mixed blood is called oxygenated blood, and it carries by the pulmonary vein. It carries by the pulmonary vein. Simply, I just already told you that artery, from artery it carries only oxygenated blood, but and vein carries deoxygenated blood. But in the case of pulmonary artery and pulmonary vein, there is a small difference, and that difference can be asked during exam. So make it sure for the pulmonary vein and difference between pulmonary vein and pulmonary artery. So pulmonary vein carries oxygenated blood from lungs to the heart. ठीक है? And from heart may be left auricle. The blood comes from the lungs by the help of pulmonary artery and comes into the, this one is your left atrium. Clear? So blood comes from the pulmonary vein and it deposits in the left atrium, and left atrium sends the blood in the left ventricle, and the heart makes the high pressure and send to the artery. This one is your left ventricle. This one is your left ventricle. So from the left ventricle, the blood, you see that the arrow, the first blood right from here, and this is a valve, and blood filled here, and the heart pumps with a high pressure and sent to the artery. And the role of artery is to carry the oxygenated blood, and you know that the walls of the arteries are thick because the pressure is high. So bear the high pressure, the walls of the arteries are high. Clear? And the blood just sent to the all organs of the body after consuming all the oxygen that in the blood by our cells, and respiration occurs there, and whatever be the CO2 is formed, that CO2 is just moved out to the blood and mixed in the blood. That blood is called the deoxygenated blood, and that one is carried by the vein. And one thing, and the main artery is also called aorta. Clear? And the main vein is called vena cava. So all the point you have to discuss here, main vein is vena cava and main artery is aorta, and the vein carries the deoxygenated blood in right atrium. Clear? आपसे पूछा जाता है in exams, what veins carries deoxygenated blood from all the organs to the left atrium of the heart, and left atrium sends the blood in the right atrium. Clear? Make it correct. The veins carries deoxygenated blood sent to the right atrium, and right atrium sends all the blood in the right ventricle, and heart with high pressure sent it to the pulmonary artery. And with the help of pulmonary artery, you see that the arrow first is, it comes here in the, this one is your right atrium, and this one is your right ventricle. Clear? And with the high pressure, the blood goes from right ventricle to the pulmonary artery, and with the help of pulmonary artery, it carries deoxygenated blood from heart to the lungs. So this process again repeat again and again, and the role of septum is asked in your exams. The role of septum is that it is a wall type structure which helps in the separation of deoxygenated blood from the oxygenated blood. So in exams the question is asked which separates the deoxygenated blood and oxygenated blood. That one is septum. And one question is also asked in your exam, what is the cell membrane? What is the membrane by which the heart covers? That one is pleura. That one is pleura. Clear? So these are the most important points about the heart. Clear? Okay, okay. So today we have to wind up the class, and in the upcoming class we have to discuss on the more different topics. Clear? So okay, thank you class.